Next, we will discuss how to integrate the powers of cosine. From the basic rules of differentiation, we know that the general antiderivative of cosine is sine. But there are no basic rules of differentiation and integration that would provide us with the formulas for integrating powers of cosine starting with 2 and above. So the goal is to fill in this gap and develop the methods for integrating such functions. Let's start with the power 2. We're going to use a trigonometric identity to reduce the power of cosine and rewrite the integrand. Then we set up a linear substitution by setting a new variable, let's say t, equal to 2x and finding the differentials of t and x. After we plug everything into the original integral, we notice that we have nothing but the function of t left in the integrand. We finish the process by finding the antiderivative and replacing t with 2x. After simplifying the expression, we obtain the answer. Let's increase the power to 3. We rearrange the integrand by chipping away a single cosine function to create a recognizable pattern. Then we set up the substitution by setting a new variable, let's say t, equal to sine of x, and finding the differential of t. Next, we plug everything into the original integral and notice how, because of the discovered pattern, we have nothing but the function of t left in the integrand. We finish the process by finding the antiderivative and plugging the original function sine of x back for t. Let's increase the power to 4. Notice that rearranging the integrand by chipping away a single cosine function and setting up the substitution by setting a new variable equal to sine of x doesn't lead to a doable problem due to the presence of the extraneous cosine function in the integrand. So we have to try something else. We are going to rewrite the integrand using the properties of powers and then use a trigonometric identity to read the cosine squared. We expand the square of the sum and use another trigonometric identity to reduce the power of cosine squared of 2x. And further rewrite the integrand in terms of cosine of multiples of x. We combine the like terms in the integrand, and using the linearity properties of integrals, we split the integral into 3 simpler integrals, which we find using well-practiced techniques. We simplified the expression to obtain the final answer. We update our knowledge with the new integrals. Similarly, we can apply the established techniques to find integrals of other powers of cosine. When n is odd, we can use the split and substitute technique, in which we rearrange the integrand by chipping away a single cosine function to create a recognizable pattern. Then we set up the substitution by setting a new variable, let's say t, equal to sine of x, and finding the differential of t. Next, we plug everything into the original integral, and notice how, because of the discovered pattern, we have nothing but a polynomial in terms of t left in the integrand. We can finish the process by finding the antiderivative and plugging the original function sine of x back for t. When n is even, we can rearrange the integrand using the properties of exponents and apply a trig identity to reduce the power of cosine squared. Applying this method for high even powers will require further use of trig identities to reduce the even powers of cosines and use of split and substitute techniques for handling odd powers of cosine, but will eventually lead to a linear combination of integrals, all of which can be found via substitution. We discussed the integration techniques for integrating powers of cosine, depending on whether it is even or odd.